Okay, we are going to look at how to draw a filled d orbital diagram for a complex metal ion. In this case, our complex metal ion is chromium, and the complex, I'll just rewrite the formula here, is chromium complexed by 6 waters, and the complex ion has a +3 charge. The first step is to determine the oxidation state on my transition metal ion, atom, which is chromium, which will be an ion. Water is neutral as a ligand, and that means the entire +3 charge of this ion must be due to the chromium, so it will be chromium 3. Now the next step is to figure out how many d electrons that we have. To do that, we can start by getting the electron configuration of chromium. Going to a periodic table, we can write the electron configuration. It will have an argon core, and then 4s2, 3d4. So we want to know the electron configuration of chromium 3. Transition metals, when they form ions, lose their s electrons first. So chromium 3 is going to lose those two first, and then it will lose one of these argons. So chromium 3 will have an oxidation state of argon 3d3. All we're worried about is the d electrons, so you may see that written just as d3. Next, we need to know what kind of complex geometry that we have. This is going to be an octahedral complex, and we know it's octahedral because water is a monodentate ligand, meaning it can only form one bond with the chromium, and there are 6 of them, so that means the coordination number must be 6, and that means the geometry is octahedral. In an octahedral crystal field, 3 of the d orbitals are lower in energy, 2 are higher in energy, and that difference will be our crystal field splitting. So since we have 3 d electrons, they're going to fill these lower orbitals first. Each one will be half filled. They can be either all spin up or all spin down. So this would be my filled d orbital diagram for this chromium complex.